Hello, everyone. Welcome to the sessions of programming in Python. This session particularly focuses on the library called as Numpy. So, in the previous session, you all have learned what pandas is, isn't it? Pandas, which had introduced to us two different data structures, which is series and data frame. The Numpy library would be introducing to us a ND array or a n dimension array. All right. So, this as a library which is introducing you a new data structure which is called as ND array. These are very high performance arrays, unlike list, in which if you store the data and if you have to compute or process on each element of a list, you would have to loop across the list, right? That is a time consuming process. But if you have to perform any operation on a NumPy array, then that operation could be performed all at once, right? So there are certain advantages with respect to what the NumPy provides with respect to dealing with arrays. Um, Something like it allows you to do vectorized operations, like what I just explained. All the elements could be computed at once. The speed is very high in NumPy, and it's very memory efficient. In NumPy array, you cannot store multiple data type of elements. All the elements would have the same data type, whether it's going to be an integer or strings or float, everything is going to be same. So, and hence it's memory efficient. It provides the scope of broadcasting as well. So NumPy allows you to perform operations between arrays with different shapes, automatically aligning the dimensions of the arrays to make the computation possible, right? So overall, NumPy is a powerful tool for numeric computations and scientific calculations, and it is used to develop many engineering applications. All right, even the pandas is developed using NumPy. So let's get started and understand what a NumPy is basically. So the very first thing that you do in NumPy, you start importing the library, right? So I would write import NumPy as np. So I'm importing that as np. If you do not have NumPy installed, I would say go to your command prompt, type cmd, and in your command prompt, you can say pip install NumPy, okay, and you hit enter. Since I already have NumPy, it would say that requirement is already satisfied. But in case I hadn't had this NumPy, it would be installing it. The same thing you could also confirm, right? So since NumPy has introduced to us the array, now let's start creating the array. How does an array is created? So let me create an initial list first. So if it's the scores that I want to store, then I would be storing it in a list, isn't it? All this while. So this is my initial list which I'm creating. Uh, we do it the same way, square brackets, different elements separated by comma here. And this list, if I have to convert into a NumPy array, I'm going to let me create a data underscore array. So this is just a notation to name my variable, which is going to indicate that it is an array. Okay. So here I'm going to say np.array. Remember, np.array is a method which is going to return you back a NumPy object. Okay. But how does it return? I'm going to take this data and put it in the parentheses here, and this data, which is a list at the moment, shall be converted to array. Okay, to see how does it look like, let's try to print this. And you see here a one dimension array has been created, isn't it? Right, so this is an array. This looks exactly like how your matrix would look like, right? One difference between a array and a list is list can store multiple types of data. It could store a mix of strings, numbers, integers, floats, but your NumPy array stores only single type of data, right? This was creating one dimension array. Now let's try to see how do we create a two-dimension array. I'm pretty sure that you would have seen a list within a list, right? So if this is my one list, maybe I can accommodate this into a larger list, and here I can say, so it's a list within a list. If I shift it down, it would be easier for you to visualize that it had been a two-dimensional list, right? So let's try to convert this into array. So I'm going to write it in a same way. The same function is something I'm going to use, and let's try to print how does it look when we try to convert a two-dimensional array, right? So you can see here that a 2x6 array has been created, right? So this is one way how you create an array. This is a way to create a one-dimensional array. This is a way to create two-dimensional array. Now, if you must be wondering why would you need an array, then remember that a lot of data, mathematical kind of data, you might want to store it in a form of a matrix to do the faster calculation. Even your images which you see, these images are built up of RGB values, which are nothing but the pixels at each point on your display. If you have to convert or process or do the image processing, eventually you are going to need to operate on those values, the RGB values, which is nothing but a matrix of values. You will have to deal in NumPy. NumPy is a good way to deal, right? So that is one. Just like how I created a 1D array and a 2D array using the existing data, the other ways to create arrays, say I want to create 0. So I'm going to write here np dot zeros, and here I'm going to write 3 comma 4. So this is going to create the zeros for me, the matrix of zeros. And you can see here that so it has to be zeros, and here I should be giving it as a tuple. Okay, so I'm giving a single entity here, but I'm giving as tuple number of rows and number of columns. So you can see here that all zeros have been created. And if I want to create ones, the matrix of ones, then what I can do is I can use ones method. This is how you create ones. So you see, NumPy gives me different methods to quickly create arrays, just like how range function in Python gives me the power to create the sequence of numbers. In the same way, there are quite a few methods here like array or zeros or ones. And going forward, if I tell you another method called as np dot arrange, okay, let's try to arrange. Let's try to understand how the arrange works and how does it create the numpy array for you. So if I write here 0 comma 10 comma 2, then remember that these arguments are nothing but the very first argument is the starting point, the second argument is up to what point you want to go, and the third argument is the uh, you can say the gaps, with what gaps you want to create. Okay, this array, if I try to print here, you shall see that okay, it's only single r. You need to remember that, be mindful that you put just single r. All right, so you can see here an array, 1D array has been created starting with 0 going all the way up to 10 with a space of 2. If I make it 100 and if I make it 20 here, then you will see that this has been updated with 0, 20, 40. If I make 5 here, then this is going to be further large because 5 is a smaller uh, distance, right? Okay, this is arrange. Now let's try to learn the other method called as line space. So in NumPy, the line space method, what it does is this also creates an array for you. However, if I tell I want to create the array within the range 0 to 1, however, I need 50 data points. So what happens is from within the range 0 to 1, this range is going to be divided into equal 50 data points, and the array shall be created for you. So let's see how does an array look like when you try to create through line space, right? So look carefully how this range has been divided into 100 points, 50 points. If I make it 10 points, then you would see that it's even smaller, right? So these are the arrange and line space functions, basic understanding. Going forward, now since you have created an array, now how do you um, slice it or index it? Now what I mean by slicing or index is obviously if I'm trying to print this whole array, then complete array is printed for me, right? However, if I want to select any certain element very selectively, then what do I do? Just like your list or dictionary or uh, series, I put very square brackets here, and within this I give the index number. Okay, so here I'm going to get 0.00. If I get if I give 2 here, then I'm going to get 0.22. So this is at the 0th position, this is at the first position, and this happens to be your second position. All right. Right. If I want to give, so suppose I have 2D array, something like this. Let me take this 2D array here. Okay. Suppose I have 2D array here, and in this, if I want to select from first row and say second column, so this happens to your first row, right? And 0, 1, 2, 30 should come. So as you can see that 30 has come up. If you want to visualize how 30 has come up, let's try to print the array first, and you can see that this is how your array looks like. And in this, when I try to give with respect to rows and columns, then first row, that means this is the row, 0th row, this is the first row, and in the first row, second column. So first column, second column, and here. So 30 is what is being given to you. All right. This is one. I can also remember, I can also access um, the content here with respect to range. So within 0 to 10, or maybe I can say 0 to 100. So how does it look like? Our array looks like this at the moment. If I want to slice it from second position all the way up to 7th position, let's see what do we get. So we get this, right? Let me also print here without slicing so that we are able to compare. How does it look like? You can see here that this is your full array and this is your sliced array. The bottom one is your sliced array, right? Um, as you know that NumPy is majorly being used for array operations. So what we just learn is the different ways to create the NumPy array, and shortly thereafter we learned how to access the array, whether it is accessing the full array or accessing the array in partial manner. These had been the different ways, right? Now let's try to see how do we do the element operation on the NumPy arrays. So if I'm creating array 1 here, something like this, so I will create a random list here, and in the same way I'm going to create another array here. So if I try to print here array 1 plus array 2, you will see that, okay, you can see that 579. So 4 plus 1, that is 5, 5 plus 2, that is 7, and 6 plus 3, that is 9. You can see here that element-wise operation has been done in NumPy array. Now, had it been a list, if you had to try to do the same thing with a list, maybe I can show you here. This list plus this list, it would have given you a concatenated list. That means a larger list that is formed using these two, right? Look at this. Yep. And if you had to do the overall operations on this list, you will have to loop through each element. But in array, you can have even the million elements of list, multiple list. You can all do such kind of operation on element wise, corresponding element wise together. And it's very efficient and very fast. And in the same way, if I have a list here, which is I'm trying to convert into array, I can also tent array. I can also do more operations like array 1 multiplied by array 2. Let's try to see how does the resultant array looks like. So if I run this, you can see here that 41080, that is the multiplication has taken place. The similar thing I can as well do with subtraction, and you can see that the resultant operation has taken place, right? Okay. Not just this, we can also perform certain mathematical functions on array. So like I said, this is a numeric computation library. The mathematical function that you could do on it, let's try to give a quick look at it. So if this is my array here, maybe I can change some values here. Okay. If I had to do the exponential function. So what I can do is maybe result equal to np dot exponential array 1. Now let me try to print here result. You can see here that the exponential has been performed on it, right? In the same way, if I had to do the logarithmic operations, then I am supposed to use the log function here. All right. So let's see what the result is. So the logarithm of 1 is 0, the logarithm of 2 is this, 30 is this, so on and so forth. This function has been applied on each array, right? And in a similar way, if I had to do more operations, for example, I want to perhaps reshape my array. So let me first create an array of certain dimension, like array equals to np dot array, and within this I'm going to create a 2D array, so 1 comma 2 comma 3, and the other element is going to be 4 comma 5 comma 6. So this is my array. Let me try to print it off. Array looks like this. So this is my 2D array, right? So if I have to reshape it, so what I'm going to do is I'm going to maybe I can say modified array. How does it look like? We are supposed to use reshape method. So I'm going to write here arr dot reshape. As you know that it's a numpy object, so object has both attribute as well as methods. So I'm using this reshape method. So I'm going to reshape it to 3 comma 2. Okay. So let me try to print it thereafter. And let me also print it before I had modified it. So before I modified, it's going to be array arr And you can see here that before it was 3 cross 3, now it is 3 cross 2, right? So the shape has been changed. However, you should ensure that when you're trying to reshape, the number of element has to be same. So earlier it was 6 elements. Even after reshaping, it's 6. So the reshaping should be in such a way that the number of rows and number of columns that you are configuring, that has to be, you should not lose out on the data. Otherwise, it will throw an error. Okay, right. And suppose this whole 2D data, if you want to flatten off, or you want to convert into a 1D array, then what you can do is you can just uh, let me do it again. You can just use the method called as flatten. Okay, so within the flatten, I need not give anything. And if I run this, you can see here that it got flattened, right? So maybe I should be trying it in some other block, and you can see that the numpy complete array has been flattened, right? Okay, now this is one. Just like how we have did some arithmetic operations like plus, minus, multiplication, and how I reshaped the array, whether I had the 2D array or 1D array, I could reshape it into different forms, right? The next thing that we're going to learn is within the arrays, we can also concatenate and stack arrays. What do you mean by concatenation? Suppose my array 1 is in a similar way, if I have my array 2 as, let me create, right? So if I do here modified array np dot concatenate is the function that I am supposed to use, and within this I can give array 1 comma array 2, right? And here after concatenation, if I try to print modified array, let's see how does it look like. I should be giving it within the as a tuple here. Yep, you can see that the array has been concatenated, right? So what we were missing is we were not giving these arguments properly. We should have been giving them within the parenthesis. Okay, and in a similar way, if I have to stack two arrays vertically, what do you mean by stacking is, suppose I have these two arrays, okay, and if I try to convert it into um, 2 array, like this happens to be the one, and in a similar way I can convert this also into a 2D array. Now if I want to stack it vertically, what I can use is I can say np dot vstack. Okay, and a similar way I have to give get this, so they have been vertically stacked. In case you want to horizontally stack them, then you can write instead of vstack, you can use head stack method. Okay, you can see that they have been stacked horizontally, right? So a quick revision here. We learned what a 1D array is. 1D array is nothing but it is like a list wherein you have one dimension sequence kind of data in the array format or a matrix format, and a 2D array is somewhere where you have multiple rows and multiple columns, right? We have learned how to convert a list into an array using array function. We have learned how to reshape it, how to flatten the array, how to concatenate the arrays. Now let's see if I have to do the generation of an array randomly. So using the methods like arrange or line space. Of course, we were able to generate the arrays using array. We were telling that using lines arrange. We were telling that I want to have the array starting at 0th position, ending at 100th position here with equidistance of 5. But when it comes to line space, I have the range, and that range I am distributing in 10 data points, right? But if I want to randomly create an array, what do I do? So I remember that NumPy inherently use random library in itself. So if I use array equal to np dot random dot rand, okay. So in this, if I tell that I want 3 cross 2, and if I try to print here array, you will see that a random array has been generated, right? Right. So this is about how the array could be generated. And now suppose you want to convert into, let me increase this array size here. I'm going to say 10 rows and 5 columns here, okay. So this is something has been generated. Right now in this, suppose I want to filter out. So you can also mask and filter the arrays. Let's take a basic example here. For example, I have data 1 equals to, if this is my scores, I have 50, 25, 45, 75, 65, 82. I want to filter this off. What I can do is I can create a mask. Mask is nothing but data 1 and greater than, say, 50, okay. And if I write here filtered data, then I can say here data 1, and here I can say mask. So this is a way to filter off your array. If you try to print here, you will see that I should have converted this into array here, and that is why the mask is not working. So if I run this now, you can see that the data has been filtered, right? Data has been filtered with respect to masking condition, isn't it? So this is how we can do the mask. And suppose I want to sort it because it is arranged in a different staggered manner. What I can do is filtered dot, I can use np dot sort method here, and now if I run it, you can see that it is sorted, right? So these are few methods that you have learned, how to create an array through different functions. You have arrange, you have line space, you have array, you have, for the concatenation, you have vstack, you have head stack. If you want to do any mathematical operation, whether it is logarithmic or exponential over the whole array, you have these methods, right? So this is something, these are the basic methods and basic functions that are available at your disposal for you to create arrays. And then uh, these array could be processed mathematically together, different computations could be performed. What arrays were that we created, these are just few elements of array, but the actual array could run into millions and thousands number of elements, okay. So we have learned basics of NumPy. Now let's try to also learn the basics of Matplotlib. So just like you have pandas, which introduced you to series and data frame to do the data analytics, even the NumPy has introduced to you with arrays to do certain numeric computations. What Matplotlib as a library does is it has given you the options to visualize the data. So you have the data frame, you have the uh, arrays. How can you visualize it? How can you plot it? So let's try to learn how we can plot. But before we start plotting it, you are supposed to have matplotlib installed, okay. The model needs to be installed, so you can open the command prompt and you can say pip installed. Yep. Yep. So it's in the requirement is already satisfied. I'm going to just start importing it. I'm going to write import matplotlib dot pyplot. Remember, you have to import it like this. You are importing the pyplot module from the matplotlib as plt. It is not necessary that you have to import plt, but it is just a convention everyone follows. Even you can say plt. Okay. And of course, since I'm going to plot my numpy arrays, so I again need to import numpy. So if it is pandas you're working on, you could also import pandas. But since you this time you're going to visualize your data, you're going to plot graphs, you need to have matplot definitely imported. Now let's create some data at the x. I'll create np dot. You know that line space creates the random data. I mean the data between the provided range. For example, from 5 to 25, I want to create within. I want the data between 5 to 25 in the range of 100. Okay, and then y could be the sign function. So maybe I'll use the sign function here. That means for x, whatever value we are going to have for x. So before we go forward, let's try to print what is x. Okay, so this is what we are going in the x, right? So this is what. Now let me calculate y as a function of x, and then if I try to print here y instead of x, now you will see that you get this here, right, as a y. Now let's see how we can plot it. So remember that I'm going to say plt dot plot. This is the very basic way. And I can say here x comma y. My x comma y is going to be plotted, and then this is a plot object. So I'll have to show, just like how you do print to get your output on the screen. Same way, you this plt method, this plt object, you have to call first plot, which plots. But if you really have to see how the plot looks like, you will have to call the show method also. So if I run this, you can see that for the value of x and its corresponding y, which is a sign function, this graph has been plotted, right? Okay. Suppose I want to give some random values. For example, x I am giving here 5, 10, 15, 20, 40, 5, and 60. And y I am giving here. So here I'm not using any array here. I'm using my list here. And I can do the same thing here. I can just plot my x and y, and you can see that x and y has been plotted here, right, like this, right? Okay. If you want to customize your graph, suppose if you want to customize your graph, then what you can do is, there is one way. You can say plt dot, here itself, before you show your graph, you can write plt dot grid. Now let's see what grid method does. It creates such grids, these square grids. Okay. And if you want to give some title to your graph, what you can do is you can say plt dot title, and within the title you can say sine wave graph. All right. So let's see how does the title looks like. You can see here that sine wave graph, the title you have got here, right? So this gives better readability. Now, if you want to give some label to your x-axis or some label to your y-axis, what you are supposed to do is you're supposed to give x label. Here I will give this is x label, and in the same way I can give your y label also. So let's see what do I get with y label. You can see here that this is y label, this is x label. This is how you can customize. All right. So this is one. And not just this, there are further ways to customize your graph. Let's learn few more. So apart from these, what you can tell is plt dot plot while you're plotting. Okay. So here is where you're plotting, right? X comma y. You can also give something called as r. This means that your graph is going to be of red color and your marking will be dashed. So you can see that it is dashed like this. Okay. And if you want to change the thickness, what you can do is you can also say plt dot uh, plot. here itself you can give. So it's the argument that you're supposed to change line width equal to 2.0. So you can see that it has changed, right? If I give 5 here, then further thickness you're going to achieve like this. Okay. And if you want a different marker, say you don't want dash, you want O, then you can give like this. O. O. So instead of a line graph, you're getting only the dots here. Okay. And suppose you want to uh, set the limits of your x and y, then you can also do plt dot x limit, and the x limit you can say the x limits are supposed to be from 0 to 10. Okay. And a similar way you can also set y limit. So y limit could be from 0 to 100. Okay. If I run this, you can see that the limits have been changed, isn't it? If I reduce it further, say I want 0 to 50 only, right? Let me take a line graph itself. So that's how you set the limits. Okay. Suppose you want to create two graphs, then there is a concept of subplots in uh, Matplotlib. Let's see how do we do it. So basically here, um, maybe I can take the x from here. This amount of code I'm going to take from here. Okay. As you can see, I have x and y here, right? Maybe I can increase the value here. Okay. I want just the values between 0 to 10 and 100 values I want. And here I'm going to say y2 equals to np dot cosine function. Okay. So y1 is sine function, y2 is cosine function. Now I'm going to create a figure with two subplots. So how do we do that? I'm going to write fig and then now if I have to plot the data on each plot, so what I have to do is I have pressed run by mistake. Let me complete the code here first. So ax1 dot plot x comma y1. Okay. In a similar way, on the axis 2, I'm going to plot x comma y2. All right. And then for ax1, I'm going to set title sine of x. And in a similar way, for axis 2, I'm going to write cos of x. And thereafter, I'm going to do plot dot show. So let's see how does it come across. So you can see here that this is the sine graph, this is the cosine graph, and I have plotted it in as a sub-axis, as a two graph together. And like the previous customizations, I can also do, before I show up, I can say plt dot grid here, right? This gives the grid. right? So this was the basic sneak peek into the NumPy library and the basic understanding of how the Matplot library looks like. You can plot different graphs here. So what I just plotted here, it's uh, x comma y. Let's try to learn here different types of plot which you see here. If you change it to bar, you get a bar graph here. You see here, and same thing if you can go for histogram like this. Okay, so these are just some basic sneak peek into how you can plot, visualize your data, analyze your data. So using core Python and different modules, frameworks, you can deal with your data, acquire data, cleanse, process everything. And then with libraries like Matplotlib, you can also visualize the data. All right. Right. So please go through notes to get a better understanding on the subject. And any queries, just let me know. Thank you.